Hello everyone. We want to continue talking about data frame, and also today we want to talk about series 2. Series is kind of one-dimensional array of any data type, and it's a kind of, it can be a part of data frame, which is a two-dimensional array. Okay, so last time we learned about generating random numbers, right? So now I'm going to create series using these two packages. What are those two packages? Pandas and NumPy to generate random numbers, pandas to create series and data frames. Okay, so what are series? Series are one-dimensional array of any data type, and then its objects behave similarly to NumPy arrays in many aspects. But data frames, as we know, are two-dimensional labeled structure. So just remember this. Well, I'm going to cut this, move this off, and then this is going to be the header for today's lecture. Okay, so what I'm going to do, I'm going to create a variable and use pandas series. This is the method panda has, and I'm going to use NumPy random method and rand_n to create 10 random numbers. And for this series, I'm going to create indexes, and the indices are just numbers. I'm going to use list, range from 0 to 10. 10 is not included, and they are separated by just one unit. Okay, so series 31, and then let's see what I created. So these are indices 0 to 9, and then these are the random numbers I generated, 10 of them. And you know, with rand_n we can create negative, positive, floating numbers, right? From 0 to negative 1 to 1, all the floating numbers between these two. Okay, so a series can be assigned attribute, name attribute while we are creating them, and then I can use name here, name equal to series 1, and this will be the name attribute for series. So look at this. Here we will see the name of that data type float. Okay, so I'm going to create another one of these. 2 to print this because I want to display both of these one-dimensional array I'm creating. Okay, so what I'm going to change this to 2, and then look what I am doing. They are different names, right? But they have the exact same index, and the numbers that are going to be generated randomly is randomly, right? So this one is this series definitely different from this one. So let's see. Okay, the first one I created is this one. The second one I created is this one. Look at the numbers. They are totally random, right? So these two are not similar. So what I'm going to show you now, I can create series, am I right? 3, and I'm going to add these two together, 1 and 2. So what do you think happens? Let me print it. Well, I want to, you know what I want to do? I want to separate them by good. Do you know what happened? So the name I gave to this print function was wrong. Okay, now it's good. Okay, so what happens? So as long as these two series have the same indices, we can add them together. So imagine if this one plus this element will give us this one, which is printed in series 3, right? So we can add them all together. So now what happens if their indices are not different? So we could add them because their indices are similar, right? Now I'm going to create another series 1 equal pandas dot series parentheses, where is that? Okay, parentheses 5, 10, 15, 20, and then index equal to 0 to 4 and 6. Okay, so what are these numbers? I didn't generate random numbers anymore, right? I just said, okay, this array, one-dimensional array I'm creating has these numbers with these indices. Okay, and then I'm going to create a second one. Print and this one, right? I'm going to copy that here because I want to print both of them. But what I'm going to do here, I'm going to say I'm changing the indices, right? 6, 10, and 14. So now I have 2 different series, and each of them have different indices. The only similar indices are 2 and 6, right? So I want to create another series 3, and I'm going to add this one to the second one. And then I'm going to print the new one that I have created. Okay, so this is the first one I created. This is the second one I created. Indices are 0, 2, 4, 6, 2, 6, 10, 14, and the numbers are different, right? Okay, look at this. This is index 2. This is index 2. Index 2, index 2, right? For the first array, I have index 2. I have element 10. Index 2. For the second array, I have element 1. So here we see there is index, new index 2, index 2 with a new element that is addition of 10 and 1. Because we had just index 0 for the first array and not the second one, the third series I made cannot add the both elements because one of the element is not there, right? That's why we have none. And the index 0 is not defined here. Same for index 4, but index 6 is defined because we have 6 here, 6 here. Element for the first one is 20, element for the second one is 3, and then element for the third one will be the addition of both. Okay, so as long as the indices are similar, we can add two series together. Okay, so now let's print the first series I made. So now we know this is the first one I made because I want to do something here. Series 1 dot. I'm going to use a method where, and I'm going to say choose and show all the elements that are greater than or equal to 0. So what we are going to see here, the only elements that are greater than 0, the one that are negative, are not defined anymore. So look at this one. The first series I made had 2, 3, 4 negative elements. And here also we have 4 undefined elements because the negative one are not chosen. Okay, so the other thing I can do using where, I can replace all the positive element with negative of those elements. Look what I will have. I will have all the negative one is replaced with the positive of this. Means negative of negative. Negative multiplying negative is positive, right? And this one also. I will have 1.33 instead of negative 1.3 because I got the negative numbers, I multiplied them by negative and replaced by these elements. Okay, so let me copy some comments here for you. So this will give us the same shape as the first original data set we had. And then for the next one, still we have the same shape, but the negative numbers are replaced by negative of negative numbers. And this is very useful when we have missing value in a data set. Okay, so what else? Here we are going to do similar thing, but let's talk about this. By default, var returns a modified copy of the array, right? The series. If we want to replace all these values and then change the whole array we had, we can use an argument in place equal true to replace the original dataset original array with the new one with the same shape, right? With the same shape we can use in place so that the original data can be modified without creating copy. It will be just change. Everything will be changed in place. So now if I write down print series 1, you will see there's no negative number anymore. So we replace all the negative of negative value in series 1 and we change this array to a new array. Okay, so mask. What is mask? Mask does the similar thing to where actually it will be inverse Boolean operation of var. Let's see what mask does. Okay, so what I'm going to do, I'm going to again create series 1. Why? Because we already changed the original data, right? So now I have the original data again, right? And now I'm going to use mask to see how mask will affect on our data set. Greater than equal 0. Look what mask does. It will get all the negative numbers as you see, and then we'll replace the positive with none, undefined. Do you see that? So it will do something inverse Boolean of what var does. So it will get all the positive value and replace them by none. Okay, so this is what mask does. Okay, so now what I want to do, I want to explain about dates. Dates. Panda has a good method for creating dates. Okay, so Panda includes good support for dates, which can be helpful for plotting data series or time series when we have a large data set. Okay, So how can we use that? And what is that method exactly? Okay, so let's from now on import numpy as np and import pandas as what? pd. Okay, data is equal to np.random. Do you remember random? Rand, and I'm going to create 100 random values, negative or positive. And then I'm going to create dates using panda date underscore range. This is the method that we are using. Starting from 1/1/2020 for period of 100. Okay, so we use range date range as method and the argument period. Okay, so what is this argument? It will create this many dates since January 1st to 2020. Why I need this many? Because I'm creating 100 random data set. And then I'm going to create my time series data set using PD series using the data, random data I created, and now the index is the dates. So let's see what we have created. Dot 5. Is that correct? Yeah, I'm showing using head or okay, I should not write it down because we already talked about what head means. Means now we are showing the top 5 rows of the data set. What else we could do? We could use iLock location 0 to 5, right? From the beginning to 5. And then what else I'm going to do? I'm going to print the tail just as a kind of review for you what tail does. And then what's the equivalent of tail using iLook? So starting from -5 because it shows the bottom 5 rows in this data set. Okay, let's see what we have. We have error. Why? It says time series is not defined. Oh, here is the mistake. Next time, I should not show my mistake. I should wait for you to find it and let me know my mistakes. To see, I will actually do that, and then whoever catch my mistakes, I'm going to give them extra credit. Okay, so from next time, whenever I have mistake, I will try my best to not fix it. So you are responsible to find my mistakes and earn an extra credit for that. Okay, let's go back. So what happens? We have a data series here, the top 5. Let's separate them with and okay, so here it is, the top 5 and the bottom 5. Do you know why I have a space here? How can I fix that? Okay, this is the participation point for this lecture. Why do I have a space here, and how can I fix that? Please let me know. Okay, so now let's do some kind of, do you remember describe? Describe would explain the statistical kind of information, statistic of the data set. So now we are going to use some other things. I'm going to print minimum, oh actually mean, sorry. And then I'm going to use str. Do you remember what str does? Time series dot, okay, what mean does now? Mean will give us the average of these the average of the values in this array. Okay, so I want to find the standard deviation. Standard deviation will be STD. And then here I'm going to write down standard deviation. Okay, and then what is the next one? Cumulative sum. And then this one I don't use str, because what str does, it will get this value average, which is just one number, right? One value, and then it will convert it to a string, right? So average is just one value, average of these numbers, this column. And then a standard deviation of this column is just one value, right? So we can change one value to str. Here, what I'm doing, I want to calculate cumulative sum using this method. And then it will be one column, because it will start from this one, add these two, and then we'll write down the summation. And then we'll add this next one to the summation of previous one, and then write down as a summation. And then it will add each of them and write down summation of the previous numbers. So that's why this will be one column, right? And then the next one will be, what is the next one? Finite difference. So, oops, print finite difference. And then how can I get that? With what method? diff. And that's going to be here. Okay, let's see what we have now. Okay, so this is the mean. Oh, now I have another, what is that? Participation point for you. So now, I want you to let me know how to round this number to 2 decimal points. This one and this one. So this is the second participation point for you. Okay? So how can I, what method do you use and how you use it to round this mean here, this standard deviation here, and all the numbers even here. Do that to see how you do that. And if there is any error, let me know why and how. Okay, so Now we know how to get the information of an array like series. Now we want to visualize this data we created. We are going to use plot with series. So we have just one array, right? So we know that series are one array. So series objects can be used with matplotlib, which is a library, quite easily to create plots of indexed data. So remember, now what we created here, this data set, this is a time series data set. These are all the date. For each date, we have a number. Let's say the price of a product or ratio of something at this certain date, right? So what happens if I want to statistically describe this data set? We have one column which is the individuals, name of individuals, and individuals are dates now. And I have another column which is the variable, which is the characteristic of these individuals. So I can create a plot that shows how these characteristics will vary date by date. So I can use, as I say, matplotlib. I can import this package, and this can be simply done by calling time series dot plot. So what is this time series? This is the data set I created, and all these dates are indices in this time series, right? And then plot is coming from this library or package. So this is a method, right? And on the series object, and this one. Okay, this plots the data via this package using some sensible defaults. Okay, so we are going to import this package dot py plot as we can say as anything more simple than this. Do you remember when we say as, like we import numpy as np, we import pandas as pd? We want a short, easier way to call this package. We can say plt py, or plt is more simple, right? So I'm going to say plt dot figure, which is one of the methods, and then the figure size, which is one argument, is 8 by 4. So this is just designing the plot with specific dimension for us. Okay, so now I'm going to use my data set time series dot plot, which is a method, and then I'm going to label it. So label is one argument, right? Label it data, and then color for this label is red. And then I'm going to again use my data set dot cumulative sum, which is a method. We already saw this. And then we are going to plot this cumulative sum, and then we are going to label them as cumulative summation, right? So this data is coming from these columns that we created. You know what? Let me again print out our data series here. Print time series. Okay, so now it's easier for me. How many data we had? We had 100 of them, right? So we have 100 values here for each of these dates, right? And then this is the rate, what's that data that I'm mentioning. They are going to be colored as red. We are going to plot this, and then we are going to create a cumulative sum of this data. Imagine another column here, right? And then we are going to plot that one also, label them as cumulative sum, and we can choose a color for that. Color equal to, let's say, blue, right? And what we are going to do, we are going to use plot plt dot legend, because we want the legend for that. What is the legend? I will show you now when we are drawing the graph. And then I'm going to change the y label to y-axis, and then I'm going to plot it finally. How? Using method show. Okay, so change the labels name for y-axis, show the plot, show the legend. What is legend? Legend show this label and this label. Okay, you know what? Look at this. One is single coated, another is double coated. Okay, let's see what happens. I hope we don't have any error. Good. Okay, so as I said, this is the data itself in the first column. The data itself, the random data itself. This will be the new column, which is the cumulative sum of the random data, right? Okay, great. So do you see that? January 2020 until April, and we have 100 data. All these points here, ups and downs, is one value, one of these values, right? And then values varies from 0 to more than 6, and also we have some negative numbers, right? Okay, so what I want to do, I want to go back, and instead of this 1000, say instead of 100, say 1000, and then run this, run this, run this. So now look, because these are random numbers, it has changed. And then now we have length of 1000 values. And then look at our data, because we have more data, 1000 of them. And then imagine now we have 2020, 2021, and then like worth of 2 or 3 years of data, and all these noises we see because we have more values in a data set rather than 100 of them. Okay, so that's it for today, and then I will start a new video reviewing this lecture and continuing to graph our own data set, the first data set that I was introducing based on states. Have a good day. Take care of yourself.